Got to do that now and then. All right.
It's not computer related, but it's money.
Money is important. Aha. All right, so this thing must be turned up loud. Let's see. Yeah, I think, there we are. We don't need that much sound. All right, so anyway, so, all right, I think I'll talk more about the class schedule later when the official time gets here to make sure everybody knows there's a little bit of information to add to that. Let's see. I want to bring this back. Come back, I say. There we are. All right, so let's see what's in the news. I think I saw an awful lot of interesting news articles recently.
Bitcoin?
Yeah, well, there's one about them down here a little later. Yeah, this one's, let's see, that one's cute. There's one about the, that hack is down here. This one's interesting. That one's very relevant to this class. That's important. I was talking about that last time. Yeah, there was more about this Bitcoin run. I guess I'll settle for this one. I thought I had better ones. So one of the major, this is like one of the top Bitcoin exchanges just got hacked. And I have to somehow get this junk out of my way. Zoom always hogs up the top inch or two of the screen. Anyway, there. So Binance got hacked. They lost $7 million in Bitcoins, and people are watching it go by. So they don't give much in the way of any explanation of what happened. They got only their hot wallet, which was 2%. There was another one about a month ago where they stole all the money out of their, the founder died and they lost the key to the cold wallet. And they said that money's gone forever. And then next week, somebody started taking that money out and spending it. So this has happened about 8 times. Bitcoin exchanges say they've been hacked and somebody inside the company is just stealing the money. And they say, oh, somebody hacked us, I don't know where it went. And you know, maybe they even do get hacked, but it would be so easy to just say they got hacked and steal the money. That's why anyway, these guys apparently did the right thing, which is keep most of the money in a cold wallet where it's not easy to steal and it didn't get stolen, if anything they're saying is true. But the whole point of Bitcoin is that you're totally unregulated, there's no financial reports, there's no transparency, so you can just totally be stealing the money and your customers will never know, and there's no government to punish you or anything. So we'll see what comes of it all. Now, I don't know what this nonsense is. Let's see if I'm on some screwy network, on staff network. Well, I'll just carry on. All right. So this one is kind of inevitable. The American political groups are imitating the Russian campaigns that were so effective. So that's one way to, that's what these guys are saying. And of course, what I would say is what the Russians did in 2016 is just what everybody has always done forever. But anyway, what they're doing is making fake social media accounts, pretending to be a large group, carefully choosing divisive issues to scream and yell and exaggerate. And somehow I'm supposed to believe this is different than politics has been all along, which I'm not seeing, but people are somehow claiming that Facebook and Google make this very different than the way it's been my whole life forever. I thought this all political campaigns ever did, is pick some issue, blow it way out of proportion, and try to make everybody on their side by lying about it. I know it goes all the way back to the Battle of the OK Corral and the foundation of America and ancient Rome, but anyway, apparently it's some new thing and we have to censor the internet to stop it. So this one's cute. This is, I didn't know this about this Tula group. This is a Russian APT group, and these guys sound great. They sound like DARPA. These are the guys that do science fiction attacks. So now they put up a fake email exchange server, and they're catching email on the way, because email is not encrypted end to end. It would be if you used PGP, but nobody can handle the key management for PGP. So what they do is they make TLS connections from one server to the next. So you can man in the middle it, and they are. They're man in the middling exchange servers. So the email goes to them, which is pretty cute. And these other ones they've done in the past are good, clean fun. They've done ones where they hacked telecommunication satellites to deliver malware. They hid malware in Britney Spears' Instagram photos. They took over the internal infrastructure of ISPs. These guys are the DARPA of Russia that do all this science fiction James Bond stuff. It must be fun to be on that team. Anyway, so this one is pretty surprising. I didn't know this, but in retrospect, it's true. We had a demonstration in the crypto class. There's a thing called the random number entropy pool in Linux. And you can do a query to see how full it is, and you can pump out too many random numbers and it empties, and then it has a hard time creating random numbers. And so if your computer suspends and wakes up from being suspended, the entropy pool is empty. And so when you call for random numbers right after waking up from suspend, it always just gives you 0, which is now causing software to crash. And there's a long argument here. This Filippo short guy, I think, is a well-known cryptographer, and he's claiming this is all nonsense. They shouldn't even have this concept of a limited entry pool and feel like when it's empty, you don't have any randomness anymore. They should just knock it off and use something like a hash function to keep pumping out numbers. But anyway, there's a huge argument about this. So it is an interesting issue, and this gets down to the fact that people really, it is very hard to understand exactly what is a random number and exactly how to generate one on a computer and what kind of random numbers are good enough and what kind aren't. There's no simple answer. But the developers of the kernel are arguing about it and trying to decide what to do, because whatever they're doing now is not working very well. Google is supposedly going to attempt yet again to have some kind of update process that will actually update the Android phones. This is the huge problem with Android phones. They're typically 2 years behind in their patches because most people don't put on the updates and many people can't get the updates. And Google has yet another plan to come up with some kind of update channel. We'll see if that works out. It is the big problem with Android. This is the big issue. I think that the main big part of the democratic platform this time is they're going to break up big tech. And it's an interesting position. I remember this happened many times. It happened when they tried to break up Microsoft. This has been a big thing. This has been the democratic position for a long time, that we have to break up the big companies. So anyway, it's interesting to read the article and see the latest argument for this. I'm not very impressed by it. I think Bill Gates was right when he said, you don't understand, big tech companies are not like the usual monopoly where they can just sit and do nothing. You have to run like mad. And as soon as you no longer have the great idea, you'll be gone. Like, they did not break up Microsoft. Microsoft fell down all by itself and Linux took over. And now Microsoft's back to being a leader again, but they aren't a monopoly like they used to be. And it's not because of government action. It's somehow I think tech is plenty competitive, but maybe I'm just a nasty right-winger. So this is very interesting. WPA made WEP safer by just running WEP and changing the key for every packet. So you couldn't collect a lot of data on the same key. And this is someone's solution. You take address space layout randomization, where you move modules. Now the current ASLR moves the modules to a random location every time you reboot the machine. But they're going to just make it reboot, move the stuff 50 times a second or 20 times per second. It reshuffles the location of all the modules in memory to stop you from exploiting memory. And this will totally stop buffer overflow attacks and use after free vulnerabilities and everything else, because modules keep moving. And I thought it was very clever. It would end that whole category of memory exploitation. However, it won't stop the layer 7 attacks. He's quite correct. It won't stop SQL injection, cross-site scripting, things where you send a message which is processed by their software and has the wrong result, and their software is untangling, chasing the memory as it runs around. This is what Bluetooth does. Bluetooth uses 81 frequencies, and it randomly hops among them in a complicated pattern. So your computer is changing the channel rapidly, and your receiver has to keep changing the channel. And it's the same kind of thing. It doesn't mean that you can't do attacks. There's a certain kind of attack you can't do, like just flooding one channel or sniffing one channel with Wireshark, but you can still send data, and that data gets sent through that channel and then gets misunderstood at the other end. Anyway, we'll see if that comes to anything. And that's this. Unhackable, new chips stop attacks before they start. This is why you never should say that. Never say you're unhackable or perfectly secure. What you can do is stop one class of attacks with your brilliant technology, but there are other kinds of attacks you don't stop. And all right. And let's see if there's anything else worth mentioning here. I think we're close enough to real time. Let me talk about scheduling stuff, which is important to you folks. We've covered Android. Like I said, Android's probably all we're going to do here. What I decided to do is do the first chapter of iOS, but I made it extra credit. It's not going to be on the final. And there are 2 quizzes for it, but they're extra credit if you want to take it. They're both up now. So that's why I don't know why people don't have me an ECA and rate my professor. Yeah. And what I'm going to do is I'm going to do the first half of chapter 2 today, the next half next time, but I'm not going to put it on the final. But there's quizzes, you can take them, and they're extra credit if you take them. It's the same book we've been using all along. This book here. Yeah, that's that book. All right, anyway, any questions about anything? Well, let's talk about iOS because I thought it was very interesting. As a matter of fact, next time I teach this class, I'll probably be able to go through iOS in a lot more detail. But I was very pleased to observe that the iOS is just like the Android, which I think, of course, is backwards. I think Android imitated iOS. But anyway, it really is very similar. So I would play it if I could find my app. There's my app. Okay. Yeah, see how much I care about your update.
One question, actually.
Yeah.
Do you find that the iOS, or the chapter on iOS, is that outdated compared to what's going on right now? Because there's a lot more.
Well, I was worried about that. Last time I taught this class, I couldn't get a modern iPhone jailbreak, but I've been told there are now iPhone jailbreaks for iOS 11. So all you need is a phone that's a few years old. So that's why the reason why I haven't pushed this class, what I need to do, I need to somehow have that available for students. And I bought a bunch of old iPhone 4s and had them in the lab that people could use. But you really need to practice jailbreaking an iPhone and using a jailbreaked iPhone. What I'm thinking I might do next time is take a couple of jailbroken iPads and put them on the internet, on like my attack server, so you can remotely control them or something. You need to somehow make them available to students. That's the thing. You can't do anything with iPhones without a real hardware device. There are no virtual machines that run iOS that are worth anything that you can actually get at. There's ones that don't work at all or ones that are super expensive. So that's the thing that's held me back. These Android emulators are so great. You really have to have something available for free to everybody, or you can't do much of anything fun on iOS. So I'm not going to do it this semester. No time for it. But maybe that's what I plan next time. I'm going to have somehow have some iPhones in the cloud because you can practice using. Anyway, so but I think this stuff is not out of date, and I think it's not bad. This book is a few years old, but I think all the stuff it's saying is pretty much true. I didn't find much need to add anything special. It's all right. So let's talk about iOS apps. And this will be, I think, very familiar to you. It is very close to Android. So here's what I'm going to do this time and the rest of the next time. So it's the security model, iOS, and jailbreaking. And so the security model. Here's the general features of iOS security. You have a boot chain, which is spectacularly secure, which Android emphatically does not have. And I remember this is why the thing I learned about this was several years ago, I had a student who developed a new jailbreak, and he taught me about the iOS boot chain. And I was just sort of mind boggled. There is so much encryption. There's so many layers of encryption. It is far more complicated. It is more complicated even than the secure form of Windows booting, which is only possible in the one version of Windows 8 on a special tablet. But anyway, you'll talk. It's very good. The code is signed, and it really has to be signed by Apple. And then there's sandboxing, which is simpler than Android sandboxing. And all the iPhones since I think the 3S have all been encrypted by default. So there's data encryption. And then you have the generic mitigations you see anywhere else, which are quite familiar to us. And we're just what we're going to spend most of our time doing in the exploit development class. If you take that, the big mitigations that make it hard to attack people, memory corruption vulnerabilities, ASLR, NX, and canaries, stack smashing. Those are the main things that prevent you from performing the classic buffer overflow exploit. And there are ways around them, but they make it much more difficult to do the simple kinds of memory corruption. So here's the iOS boot structure. You go through 4 stages. There's a boot ROM, which remembers when the power's off. That starts it up. This loads the next step, the LLB, then iBoot, and then finally get the kernel, which draws the desktop. And each one of these is encrypted and signed and verified. And this, by the way, is the model of OS security. The iPhone was essentially the perfect computing platform where you cannot put viruses on it or rootkits or anything pretty much. And everybody else imitated it. And Microsoft in particular just keep getting closer and closer to the iPhone. And so does Android. If you get tired of everybody having their machine full of malware, you move closer and closer to this. And it also is extremely attractive from a financial point of view because it means you absolutely control everything on that thing from the corporation. And that's what Apple does. Apple demands 30% of the gross receipts of every app in the store. And you cannot get any app on anybody's iPhone without going through Apple. And they rapaciously just demand a huge price and will not let you compete with any of their stuff and will kick you out. And they carefully manipulate the store to break in piles and piles of money. It really is a very attractive business model, in addition to being very secure for the end user, as long as you're willing to play by the rules. But the rules do mean that Apple gets a monstrous pile of money from everything you do. That's why I remember when I bought my first Mac years ago, I said, I know they're going to turn me upside down and shake the money out of my pocket, so that's going to go on forever. It's just like you get a luxury car. Now, everything's going to cost 5 times as much forever. But if you're willing to pay that, you get a really nice ride. That's what it is. And it's really nice stuff, but it's very expensive, and you keep pouring more and more money into it. And Apple get piles and piles of money. So the boot ROM contains the public key for Apple CA. So you cannot boot any OS that does not come from Apple, that is not signed by Apple. This is why a lot of Linux people get mad when every time Microsoft tries to implement this, the Linux people scream, how are we supposed to put Linux on our PC if you do this? And Microsoft is saying, only 1% of our users want to put Linux on the PC. The rest wish they could just use Windows and it wasn't all infected with crap all the time. So in fact, doing this would probably serve most of our customers better. And you guys will find some way to hack it, which they always do. But anyway, that's the point. So you have to get an official signed OS. Then you go to the low-level bootloader. This finds the next level, verifies its signature. If it can't verify that this is authentic signed code, it boots into emergency recovery mode, where you have to download a clean version from Apple. And so then iBoot loads the iOS kernel the same way, and the iOS kernel is what starts the normal environment where you have the apps you want to use and your ability to log in and all that jazz. All right. So every iPhone ever since the 5S has a security enclave. This is the equivalent of the TPM chip. The TPM chip is named after the Orange Book, the Navy US government military specification for security. You must have a trusted computing platform, and they do that by adding a trusted platform module. And the point is, if you're going to have all that cryptography, signing everything, you have to somehow trust your original secret. You have basically a shared secret of some kind. You have this key that can't be changed, and you have to put it somewhere on the machine. And if you put it in the address space of the processor, then malware could find it and steal it or change it. So you have to have somewhere to hide secrets, and that's what this special chip is. It's a mathematical coprocessor chip, so the fundamental cryptographic secrets live in that chip, and you cannot even address them from the processor. You can send an instruction to the coprocessor saying, use your secret key and decrypt this stuff. And it does that, but you can't read the secret key, and you can't change the secret key from outside. That's how it works. And that's why one of the big accomplishments at Noisebridge and Jailbreaking and his gang is they actually managed to dissolve a trusted platform module on a PC with acid and reach in with a microscopic needle and suck the secret off it by finding a little piece of metal in there it was on, which is sort of supernatural, heroic. But they make it nearly impossible to steal the secret from that chip, and that's the point. And that's the point of the secure enclave. So this is the point of it, and this therefore also holds the secret for your touch management. So if it memorizes your fingerprint, the fingerprint data is stored in the secure enclave and is therefore considered very secure. But of course, yeah.
The TPM chip, is there a software available, like a hacking tool available to hack it? No, or not yet?
That's a very good question. The TPM chip on a computer, as far as I know, there is no software attack that will get it. Now, there are ways to get it. Like I said, there are ways to do it by physically dissolving the chip. And if you have a computer in sleep mode, then it has already been decrypted and the key is still in RAM. And you can then freeze the RAM and put it in another machine and boot from Linux and steal it there. But to get the chip itself, you cannot get it from anything in the processor. That's the point. It's basically air-gapped on PCs, but on the iPhone, it's not really. And I think that's what's coming up here. This is the attack. There is an attack against it. It's not in your book. This is from NCT Group, where some of my students are now pen testers. And I've told you about their tools. There is apparently a cache of some kind. Apparently the secure enclave is not air-gapped. It's not a totally separate chip the way it is on PC motherboards. It's a different part of the processor, and it shares a cache with the rest. So Spectre and Meltdown showed that you can peek past security boundaries on chips because in order to make the performance faster, it does share some components between the high security and low security parts of the chip. And apparently the same thing's true of the iPhone. So there is an attack, a software attack, which does gain some information about the secrets, because this is the fundamental problem of all computing, is convenience versus security. So to make it faster and cheaper and use the battery less, they've cut some corners, and there is some leakage of data out. So nothing is perfect. If it was perfect, it would cost too much. So anyway, that's a very good point. Nothing is ever perfect. This is very good, far better than any other computing platform. I think the iPhone is your safest computing platform, but we didn't pay enough to make it 100% safe. And that's why when Obama got in office, Obama started this. Obama had a BlackBerry, and he really used it. And the way he won president is he was heavily into social media. He was better than any other candidate at that time. He had Facebook groups and everything, promoting him so he wouldn't give up his BlackBerry. But when he became president, they said, dude, can't use a BlackBerry. That thing's not safe enough. So they made a special military hardened BlackBerry for him to use. And there's a huge argument about Trump. They're all saying he shouldn't use a normal iPhone. He should be using a special NSA military iPhone, which I think he is not. But they're quite correct that consumer devices are not really secure enough because they have to be cheap. They really ought to have a better device for people in really high powerful positions. Anyway, so this secure enclave is the ARM trust zone. And like I say, it is apparently inside the processor, part of the processor. It's a partition itself inside the processor and supposedly protects it. And since it's not really a separate chip with an air gap, there is some leakage. But it is still considered very good. All right, so then you got you restrict your processes with code signing. So every time you launch an app, it verifies the signature. Notice this is very different than Android. Android only looks at the signature when you first install the app, and only looks at it again if you try to update the app. Other than between, it never looks again. But this validates it every time, and it has to be signed with a trusted signature. And your trusted signatures are basically, it's got to be signed by Apple. You can have a provisioning profile from a developer, but that also has to be signed by Apple. Everything has to be ultimately approved by Apple. Now, this is something Microsoft does too. For example, if you get a Microsoft server, they require every driver to be signed. And there's two kinds of drivers. There are drivers that are signed by Microsoft because you actually sent it to Microsoft and they tested it. And then you can put a label on the box saying designed for Windows 7, designed for Windows 10. And there's third-party drivers which still have to be signed but may not be approved by Microsoft. And there are settings in the operating system to decide whether to accept those or not. And Apple has the most extreme setting. You can't run anything unless Apple has approved it. And the original iPhone, everything ran as root. There were no app store, no apps. Everything was just Apple code. That was where they started. It was a phone. Nobody thought for a long time about putting other software on the phone. You just have a phone that came from Apple and everything 100% is made by Apple. And they never really released their hold on it very much. And that's great for security, of course, because they actually do keep the junk out of the store, which Android emphatically does not. Google Store is full of malware, and the Microsoft Store was laughably 90% malware until they just gave up. But the Apple Store is almost completely free of malware, so you really don't have to worry about it. And that's the game. So they ban all sorts of risky activities. They won't let you have private APIs. You have to obey their rules. You can't download code and install it from some third-party server like websites do. They put up an ad, just put junk in there. They limit all this stuff. No hacking tools. There's no antivirus. There's no firewall. They don't mess around. There's no Nmap. All the fun stuff is not there. They don't want any goofy stuff happening in the store. So there are two accounts on your iPhone. There is root and there is the user account. And every app runs the same user account. It is not like Android where every app has its own separate user account. So they run in a sandbox and it's isolated by this thing called this XNU sandbox kernel extension, which limits them to stay in their one. Each app has its own data folder and they can't peek into the other app's folder, but it is not that they're running as a separate user account and using the Linux kernel to do that the way Android does. They're using a special extension here to limit it. And so this was introduced as seatbelt in 10.5, the Apple Sandbox, to limit apps from seeing each other. And they updated it to the App Sandbox and they made it mandatory. And so it's been through several levels of versions, which is true of all iPhone security. And then it has permissions, just like Android. Remember we talked about this, Android has the app and it says you have to have permission to see the microphone, the GPS and everything. Apple now has the same thing since iOS 7. They didn't used to have it. It used to be any app that's on the phone can access any part of the hardware, but they decided to, because people worried about it spying on you, they said now you have to get explicit permission from the user to access things like your stored pictures and the microphone and stuff. And so it's the same thing. And you have the whole device is encrypted, which is an option in Android, but it's not always turned on. It's been on by default in iPhones forever, since 3S or something. So the entire data system is, file data system encrypted with AES, and there's a key stored on right at the start of the flash storage. And so if you remote wipe the device or you reset it to factory defaults, it just erases that key and that's it. All the data is completely gone, and that has been verified by third parties. Several years ago, a forensic company bought 100 used iPhones off eBay and tried to recover the data from them. They were not able to recover any data from any of them. It is very easy and quick to erase your phone and incredibly effective. Everything has been encrypted right from the start. When you delete the key, it is gone, gone, gone. You don't have to spend hours wiping the disk the way you do on PCs. This is extremely effective. And so what it means is when you boot up the machine, it has to decrypt it, and then it has to store that key in RAM. So while the machine is running, this encryption doesn't protect you at all, which is generally the case. So file system encryption. The only thing encryption does is protect data at rest. If the device is turned off and you physically steal the whole data, that's what the threat that this stops. If you have some kind of attack, like a malicious app, or something like a SQL injection or a social engineering attack, where you somehow have the device running and it's doing the wrong thing, none of this does any good because the running device has the key and is decrypting the stuff. That's why, for example, some people talk about putting BitLocker on servers. And I say, this seems to be from someone that doesn't understand the concept. The only point of having BitLocker on a server is if your threat model is someone is going to turn off the power, break into the building, and physically steal the server. That is the only thing it would stop. And that is probably not the realistic threat against your server. Anyway, unless maybe your server is like in a tank or something. So, all right, so you have the data protection API. This is what you use to encrypt individual devices. This is a key that came from the passcode, which you type in. And so this, there are various levels of protection here, but that is the layer there. So here's some exploit mitigations. This one is write or execute. There are many different versions of this. The original buffer overflow attack for Aleph Null from Frack magazine was you find a string variable, like a password or something, where it only has a certain number of characters, like 10 characters, but you find a way to inject like 1,000 characters. Now you have a bunch of data in RAM that in a place where the developer didn't intend for it to be, and you overwrite control structures, which are used for addresses. And you ultimately execute part of the data you put in as code. So you have data that was written as a string variable, and then you run it as code. And so to prevent this, you have permissions on memory. And the classic solution is write or execute. Every memory segment, which is defined when an app launches, has to be chosen either to be where user input goes, and that will be writable, but it cannot be executed, or it's stuff where the developer wrote code, and that is executable, but it can't be written to, so nobody can change the code while the app is running. The code has to stay unchanging and run, and the data changes, but none of that's executable. That's the plan here. And that's XN is ARM's feature for this. On PCs, it's the NX bit. Microsoft calls it data execution prevention. It's all the same thing. You have permissions of a sort in memory. And so the idea is no kind of memory corruption attack that abuses the input data can lead to code execution, not easily anymore. There are ways around it. The simplest way is return-oriented programming. You input data, and the data is just a set of addresses, and the addresses point to code in the executable memory, and you run that. That's the cure. That's why there's always a way around every defense. And this is like building a, we'll do it quite a bit in the exploit development class. This is like writing a letter by cutting out words from the newspaper and pasting together like ransom note. You don't have the ability to write, so you take little pieces of the other stuff and paste it together. You have to take pieces of the code that is already there and piece together your exploit. And then what you write is just a list of addresses, which is not executable code. That's the solution here. Now, this only works if you can find a block of code and see what it is and take the pieces and chain them together. So if you have address space layout randomization, randomly moving the code around, this becomes very difficult to do. And that's the point. ASLR and the NX and data execution together, the data execution prevention together, make it very hard to perform memory corruption. There are always ways around it, but that's the point. It is a big step forward. So ASLR is a big defense, where you randomize the locations of things so the attacker can't build their ROP chain because they can't find those fragments and run them. All right, now the way you get around this on Windows, which we do a lot in the exploit development class, is it turns out that none of this is perfect, and the same thing's true of Android. Not everything is really randomized. There are parts of the operating system, and there's especially legacy code written by developers. If you're using code that's like 10 years old, then it's not got the right compiler switches turned on to implement ASLR, so its location is in fact not random. And there are parts of the operating system that are not random, and so you just exploit them. So that's the point. In iOS was the same problem. The part called the dynamic linker was not randomized. Old apps that were not compiled with the right feature, position independent execution, cannot be relocated. They're compiled to sit in just one memory location, so they can't use it. And anyway, that's the game here. Those are the weaknesses. Same thing's true of Windows. If everything was really 100% randomized, and especially like that news article, they kept on re-randomizing several times per second, it would get really hard to exploit. I'm sure there is still some way to do it, but that's all any security defense ever does, is raise the bar. And the attackers have to raise their game. You know, nothing's ever perfect, but you certainly can wipe out a whole generation of attacks and malware by raising the bar a good bit. And that's what these things did. Stack smashing is another one. You put a stack canary on the stack. This turns out to be expensive, I guess, because both on the iPhone and on Windows, the compiler and the loader does not implement this all the time. It judges whether a routine looks risky, and only does this if the routine looks dangerous. In Windows, it looks at your code to see if there is actually a string variable longer than 5 characters in your code. But it thinks that an injection is probably not possible unless you have one of them. Then it puts a canary on, so you have the local variable stored on the stack, and it puts a random value at the end of it to notice if somebody's been overwriting a local variable, running past the end of it, changing things. Then it will say, and then it will not run the code anymore when this happens. Every time it returns from a routine, it checks the canary value, and if the canary value has changed, it will abort and put up an error message and kill the process and say this process is not usable anymore, because that's how the attacker takes over. They overwrite that return value, and when the app tries to return from a code, it actually jumps into the code the attacker put in there. So this is specifically to stop the classic buffer overflow attack, and it's really quite effective. So it's available on modern versions of iOS also. All right, so you got 3 kinds of apps. You got the standard apps, browser-based apps, and hybrid apps. In Android, all the apps are written in Java, and they run in a Dalvik virtual machine, which is a Java virtual machine designed to run faster and use less memory. In iOS, the apps are like Windows apps. They're compiled right down to real machine code to run on the processor, all the way down to ARM code. So this is called native apps. You write them in Objective-C or Swift, and you compile it with a thing that's basically a C compiler down to assembly code, and it runs in assembly code. So it's linked against the framework, and so that's one way to write an app. That's the most common app, running right in assembly code, just like PCs. Browser-based apps are things where the app is really on the server and it's just a web app and you're really just viewing it through the browser. That's another way to do it, of course. This is popular, of course, for developers because then it kind of doesn't matter what version of the phone you have. You could even have a platform-independent app. It's pretty much the same on Android and iOS because it's really just a web app and all the code is on your server. That would be one way to go. And then you can have hybrid apps that mix these two things together. All right. So you're going to distribute your app. Almost everybody, you want normal consumers to get your app and perhaps to pay for it. So you just want to be in the App Store. Normal iPhones that consumers have, the only thing they can do is load things from the App Store. So you have to go through Apple's approval. Apple has to get a 30% cut of all your money. And this is why I remember I got the Kindle app. And when the Kindle app came out, you could buy books inside the Kindle app for about a month. And then Apple said, wait a minute. You can't be doing that because if you buy books inside the Kindle app, we don't get our cut. So we're going to kick you out of the store. So, okay, fine. Now you have to go to because they don't do that anymore. Now when you want to buy a book, it sends you back to the browser to go to the store where Apple gets their cut because Apple is real strict about this. They get 30% off the top, and they're now getting sued from Europe saying that is rapacious and evil and that's too much. But that's the way it is right now. Apple has got away with that in America by being a luxury product. That's why I never understood Steve Jobs freaking out about Android. Apple's whole business model has always been to be a small part of the market. They're only like 5% of the market, and it costs like boldly 4 times as much. And they don't ever get sued because they say, well, you could just buy a PC. It's not like we're forcing you to buy this expensive luxury product. And that's a pretty good model in America. Antitrust will never touch you. When there is a more popular, cheaper option, they can't claim your monopoly. You can't claim you're abusing your privileges. They say people pay this because they want a better product. Anyway, so that's the game. The App Store approval has both manual steps and automated tests, and it's extremely effective at removing malicious apps. There are other ways to do it, though. You might want to write your own in-house iOS app, and you might want it only to be available to people in your company and not in the public store. And so if you're going to do that, you have to have some kind of certificate. So there's 2 ways to do it. If you're a developer, you can join the Apple developer team and get a developer certificate, and that will let you test apps by installing it up to 100 phones. But if you want to really distribute it to a large company, you have to make a deal with Apple. And Microsoft has the same thing. You can make a deal with Microsoft and say, I'm like HP. I need 100 million Windows licenses. And they will sell you a Windows license that can be used an infinite number of times to activate machines, not one by one. And they're very picky about that because those things leak out and get abused. And it's exactly the same here. Apps have to make a business partnership with Apple and convince them that you're a serious, big, legitimate business and they can trust you with the ability of having your own app store and install stuff. And then they'll trust you with that certificate. And it's not easy to do. And in fact, it has leaked out. The same thing happened with Windows. Those certificates, those keys that were good for an infinite number of uses leaked out in the public. People used them to activate pirate copies of Windows. And people took these developer certificates and used them to make jailbreaks and malware on the iPhone. And of course, now they expired and got canceled. And that's why the Panda jailbreak, I remember I did this, with jailbreak my phone with the Panda jailbreak, and I was so surprised. It reboots 3 or 4 times, and it set your clock back several years. And I wonder what that is about. It set your clock back several years so you can use an old expired that leaked developer certificate. So it can put on unapproved software, and then you break in. So, you know, that's why I remember back in the days of XP, there were students that had this product key memorized, which I think ultimately leaked from HP. There was one famous key, XNPP or something, that you activate every Windows XP everywhere because it was one of the same thing happens. You know, that's why there's a real problem here. Companies that want to really use a lot of your software really need a way to get out of your activation process. But if you do that, it's going to leak. And then you've got this problem. Anyway, so the app structure is very much like Android. You've got an IPA archive, just like Android files. It's a zip archive containing everything. These are the 4 things in there. There's a payload, and the main thing in the payload is this one file called application.app, and that has the whole app pretty much, all the data and resources and everything. And then you got the artwork, which is just the icon to put in the store and on the desktop. And you have metadata, which is stuff like the copyright info and stuff. Most of the goodies is in this app file. And every app in the early days, as you had permission to everything, total control of the phone, and then they added the permissions like Android, where you have to get permissions to access these things like microphone and motion sensor and photos and all that jazz, and get the user to approve that. And you'll now see privacy prompts like this. This wants to access your contact. Do you want to allow that or not? Just like what happens in Android. And for the same reason, because it's very hard now to write malware that will do things like steal your photos. So, and then after you do make a decision, it's in your settings which app is allowed to do what. These apps are allowed to reach your contacts and so on, just like which apps are allowed to use your limited bandwidth to make updates and stuff. That's how it works. So iOS 8 has got 3 values for location information. Never allowed only while the app is in the foreground of use, and always allowed. This is common. So you might want something like Find My iPhone. You probably want it to always have access to location information, things that are tracking to push pads onto the thing. You wouldn't want that. Well, I don't know how much of that there is on the iPhone. Anyway, then there's jailbreaking. So if you want to actually have complete control of your device, and if you want to do good security tests on your device, you have to get out of this framework and get complete control of the device. And that's what jailbreaking is. And by the way, I didn't mess with it yet this semester, but the legal status of jailbreaking just keeps blowing back and forth with the wind. Obama declared that it's legal to unlock your phone, which means move it to a different carrier. So the carriers can't lock you in. But jailbreaking is a violation of the Digital Millennium Copyright Act. You're defeating a cryptographic security boundary put there by a developer. It is essentially software piracy to jailbreak your phone. And a Digital Millennium Copyright Act does have the ability for there to be temporary exceptions to this act. You have to apply every year, and you can get a category of devices approved for a 3-year period to make it legal to jailbreak them. And phones are frequently in that category. Every few years, phone is legal to jailbreak. Then a couple years later, it's illegal to jailbreak. I don't happen to know what it is right now. I know it was always illegal to jailbreak your tablet. Not because anybody thinks that's wrong, but because they could not define what a tablet is for the law. This is the same reason why most cybercrime laws make no sense, because you can't really define what an attack is, and you can't really define what a virus is, and you can't write a law unless you say exactly what it is. So what exactly makes a tablet different than a PC? Is it the keyboard? Is it the size? Is it the weight? Is it the power? And if you don't make that clear, you're either letting it legal to hack everything. So tablets, they couldn't define them. So they couldn't make it legal.
Well, if it's a phone chip in it, then it makes something else.
The phones can make phone calls. That was the magic thing. You could.
Your phone should be your tablet, so you can have internet.
That's not making a phone call with a human talking in a speaker. That was the thing that made it possible to define a phone. Making a phone call like Alexander Graham Bell. They could understand that. That was a legal definition of a phone. And if it doesn't do a phone call, it's not a phone. You can do Skype, but that doesn't count. And FaceTime, that doesn't count. That's not a phone call. So it's illegal to jailbreak it. And this might sound stupid, but this is the way the law is. You've got to have rules, and you have to be able to tell whether you broke the rule or not. This is like Zuckerberg they're saying, we hate you. You have to take all the bad stuff off Facebook. And he's like, well, you got to tell me what the bad stuff is. You got to give me a rule so I can tell if I'm obeying the rule. And they say, you should know what bad stuff is. It's not that easy to know what bad stuff is. Anyway, so here we are. So The risks, of course, if you jailbreak, you have now subverted the Apple security model. You have now quit playing in the safe walled garden controlled by your parents to keep all the bad people out. Now you can run anything. And so now you can put malware on your phone. So iKey was the first iPhone worm that spread. All it did was rickroll your phone and changed your background to Rick Astley. But it would affect your phone because most people that jailbreak their phone are wide open because all your apps run with the default password. The root password is Alpine. And so most people don't know that. They jailbreak their phone, they install OpenSSH, and now everybody can just get in with the default password, just like your router, all the IoT things. You've lowered your phone to an IoT device now, unless you actually understand what you're doing and change the password. So a bunch of these, iKey B was a later version of this, and then this thing came out, the Unflod baby Panda attack came out and infected these machines and just would steal your Apple ID and password by putting keyloggers on your phone. There's been a bunch of worms, but they almost all only affect jailbroken phones and stupidly jailbroken phones, which is, of course, most of them. If you actually know what you're doing, you can jailbreak your phone and then put in security. But you have taken on responsibility of putting on your own security. And unless you are knowledgeable enough, you would be a lot wiser to just leave it the way Apple made it, because Apple really secured it very well. As long as you're willing to pay by their rules and only use approved things and let Apple take 30% of the money, then you'll be nice and safe and protected. So anyway, untethered jailbreaks are what most people want. This is where you modify your phone. It's permanent. You can now reboot it and carry it around and use it with no restrictions on into the future. Tethered jailbreaks are much easier to do, where it must be connected to a phone with a USB cable and the phone to a computer with a USB cable, and the computer alters the boot up sequence. That is typically how you do it. And then there are semi-tethered ones where you can start it into a jailbreaking state and you can use it in jailbroke while it's connected to the computer, or you can unplug it and reboot it and it will go back to an unjailbroken phone. That's untethered jailbreaks are the most valuable, but the hardest to make. And those are the ones like Jailbreakme. Jailbreakme was bloody awesome. And all these things are root exploits that take over the phone completely. And so they develop them in secret, and then they blast them out publicly. For like a couple of weeks, everybody jailbreak their phone, and then Apple rushes out a patch. And then you can't jailbreak your phone anymore. And Jailbreakme had this site, jailbreakme.com. Every couple of years this happens. They have a new one come out, and you can go to jailbreakme.com, and all you have to do is slide a button, and your phone is jailbroken for like 2 weeks. Then Apple pushes out a patch, and the game goes on. So that's the game here. This one here used an integer signedness issue to gain code execution, a sort of overflow. Then it used a return-oriented programming payload to escape the non-execution policy, and then it used a type confusion vulnerability. It had a chain of vulnerabilities. Brilliant people spend thousands of hours developing this stuff in secret and then blast it out to the world, and everybody can jailbreak their phones. And most people are doing it just for software piracy. The main reason you do this is to run pirated apps and stuff. Evasion is actually very clever. I wonder where this name came from. I heard of it. These guys do not use memory corruption exploits. They use logic flaws. There's a lot of attacks, like a bunch of attacks on phones are not really technical. They're like, you make an emergency call, then you swipe to the left, then you press this button 10 times and poof, you're getting this. Not really like a complicated mathematical thing. You just find a way to take the pieces and line them up funny. And that's what this was. This one, the lockdown D service would allow you to change permissions of files. And then another USB driver would allow you to call a function in another file. So you were able to combine these and get in. It was not, a memory corruption exploit. It was just finding little errors in the way applications work. That's where the evasion works. There's a variety of that. So anyway, this is what we need. This is why I'm not doing it this semester. In order to have any fun with iOS, you need to really have jailbroken devices to work on. So you have to jailbreak your device, then you install OpenSSH. Once you jailbreak it, you get Cydia. Cydia is the pirate app store, like the Pirate Bay. It's where it's the unrestricted app store for iPhone apps that only run on jailbroken phones. Most of them are stolen pirate apps, but a lot of them are open source Linux apps ported over and stuff. So then you install OpenSSH. Now you can make an SSH shell in your phone. You can log in and you get complete access to the file system, and you can see what's in there. The normal apps run under the mobile account, and the password is Alpine. The root account is root, and the password is Alpine. If you haven't changed it, that's all it is. Now you have root access to your phone, just like you have on your Genymotion emulator. You can see everything and mess with everything. What I learned the hard way, once you have jailbroken your phone, there is no going back. Apple says this voids your warranty, and they are not kidding. If you make an iTunes backup, I thought it was like a Windows image backup. They said if you file up your phone, you can just restore it from backup. So I jailbroke my iPad. Then I wanted to change my MAC address because City College had a MAC address limit then. I couldn't change my MAC address, so I tried this technique and that technique. I finally found like a pirate iPhone app from like 3 versions earlier that would change the MAC address on my iPad. And it did, but after that, things didn't work very well because it was horrible and broke it. And I tried to restore it, and it doesn't restore because the Apple backup is not an image backup of the entire phone. They make it sound like it is, but remember, they don't think you're in control of your phone. What the Apple backup is a copy of all the areas that you should be changing on the phone. It's the app directories, which is all you're supposed to have permission to get to. It doesn't back up the rest of it, which is where you get if you jailbreak it. I jailbroke it, installed all this software with piling stuff on it, and it doesn't back any of that up or restore any of that, because Apple's opinion is you should never be going there anyway. So there is no going back unless you actually use anything like DD, the backup with Linux utilities, which I didn't know. So, they're not kidding. Once you jailbreak your phone, it's very likely it will never really be back the way it was before. Anyway, so Cydia is the open app store. Big Boss recommended tools is the equivalent of BusyBox on Android. This puts on all the command line utilities so you can do it on a Linux. Just like Android, they have removed most of the cool command line utilities because they really don't want you messing with it. It's a production device. You're not supposed to be opening the seal and tinkering with it, so you don't get any of the command line tools. You have to put them back in. This puts on apt. You can do apt-get to install stuff, which is pretty awesome. Apple has CC tools. This is what Mach-O is the format for Apple binaries. It's ELF for Linux and EXE or COM for Windows, and it's Mach-O for Apple, iOS. That's their file format. So you can run this thing on either an iPhone or on OS 10 or on Linux, and it will then let you open and mess with it. The main tool is O-Tool. This is the tool that will open up and inspect Mach-O binaries. And like I say, next time I teach this class, we'll probably be playing inside here like we've been playing this time with Droger. We'll be playing inside these binaries, assuming I have a good way to have it. I think I'm gonna get like 5 iPads and connect them to on a cloud for remote use. Maybe we can have some hands-on projects for a whole class of people, but I haven't quite worked out exactly the best way to do that. Anyway, this will let you look inside the binaries, see the methods. NM shows the symbol table. LiPo lets you open apps and remove part of them. If some of you did this horrible project, the Home Depot project, and suffered greatly because the Home Depot has several different versions of their app. And one of them, the one I originally wrote, would download 4 copies of the app for different platforms, and you'd have to mess with them. That's called a FAT executable in iOS. You have multiple different hardware platforms supported by the same app. So the app is actually a bundle containing several different apps. And LiPo is the tool that lets you pick one of those out for analysis. Then there's debuggers. I was sort of pleased to see the main debugger is good old GDB. Same thing we use extensively. GDB is the classic command line debugger for Linux, and you use it on iPhone too. It is famous for being hard to use and user hostile, and it is, but in my opinion, all attempts to improve it are useless, and you just need to learn how to use this thing. I learned how to do like 3 or 4 simplest things on it, and that's all I go, but it works. It's once you get used to it, it's perfectly fine, familiar territory. Good old GDB. You can totally see what's in RAM and mess with it. Apple has now you need to sign your code. So there's code sign is Apple's tool, just like we use jar signer in Android to put a signature on there. Of course, it's not going to be an official Apple approved signature, but if you have a jailbroken phone, you don't need one. And then there's a code signer here from Sorek. Sorek is the guy that made most of this, made Cydia the main hacker that developed all this stuff. All right, install IPA is the tool to install unsigned IPA files, which is cool. Of course, only on jailbroken machines. All right. And so now you can install the file system. If you have jailbroken your machine, you just have a Linux file system. You can go everywhere and see everything. And it is just a standard Unix file system. It's a modified version of Unix, just like OS 10. If you connect to a computer with USB, like USB debugging in Android, you have to agree to pair. It says, okay, do you trust this computer? And then it stores a permanent record locally, and you can use it. Now, if you have a non-jailbroken machine, you can also pair to your phone, to your computer with USB, but you're not going to get access to the entire file system. You only get the part of the file system that Apple wants you to get at, which is where you're storing media and music and stuff. And there's apps like iExplorer and Funbox and iTunes backups, and they only access the part of the file system that Apple thinks you should be using, not the OS part of the file system. So on a jailbroken device, you have access to all this jazz, private VAR, voicemails, SMS data, videos, contacts, and so on. The information about the phone is stored in plist files. This is a binary format. For some reason, just like Android, they have XML and then they turn it to binary for some stinking reason instead of just using plain XML, and that's what this is. These are the parameters. Serialized objects and key value pairs, and they have a utility to turn it back into readable XML, which is one of the things that APK tool does, is unpack the Android XML to real XML you can read. They have binary cookies for some twisted reason. I don't know. They're the same thing as normal cookies, but for some ungodly reason, they store them in binary format just to give us all a headache. You have to use the binary cookie reader to turn them back into normal cookies. And you store your data in SQLite just like you do on Android, so it's very similar. All right. So I got some hoots about that, and we'll do more of it next time. And I see we're right on track here. And I also observe that I'm somehow not charging, but I guess my battery will last long enough to do the hoots. I don't have to figure out how to solve that problem. So, all right. I plugged into something, but probably turned off somewhere. The power on campus is too much bother to figure out. I should have favorites somewhere. Here, favorites. There they are. And it is 128, chapter 2A. There we are. And let's see if I can have a place to put the scores. Okay. All right, good. Yeah, looks like 8 people online and about 8 in the room. There could be some more coming. All right. All right, I'll give it a few more seconds. Okay. Okay, which step falls into recovery mode? All right, that's the LLB step. Will fall into recovery mode, the second step of boot up. All right, what feature was seatbelt when it first came out? That was the Sandbox. The original iPhone had no apps. Everything just ran as root. Everything had full access to everything. Then they brought out apps, and then they developed Sandbox, and they started out by calling it your seatbelt to make it safer to run apps. All right. Which mitigation uses XN? Okay, that's non-executable memory. Intel calls it NX, Microsoft calls it DEP, and ARM calls it XN. All the same thing. You can have a region of memory that cannot be executed. And if you attempt to jump there and execute memory, you will trigger an exception and stop execution, which stops a lot of attacks. All right. Which mitigation do you bypass with Rob? You overcome non-executable memory. Instead of inserting code to run, you just insert addresses which point to other code which is executable, and you run that. You don't actually inject any instructions. You use the instructions that are already there to paste together to build your attack. All right, what was the first worm? iKey, Rickroll of all the iPhone users. Right. What's the default password? Just like your router, just like all the insecure devices, there's a default password on all the iPhones. This is, yeah, I know it's ridiculous, of course, but they lock you out of the OS. So it's actually okay for everything to have the same password as long as you don't jailbreak it. But everything has the same password and that's it. So anyway, all right. So we have WITB, who I think they told me who they were yesterday, but I don't remember. Forrest. And M, my grader might remember it, I don't remember. So, oh, I remember yesterday, I got a message. I remember who WITB is, all right. I got it. All right, good, and he's saying he's chatting to remind me anyway. Yep, that's right. Yep, good, I remembered it. Good, all right, so that's it. Next week, I'll finish this chapter, and it's all extra credit. If you take the quiz, you do the Kahoots. And so we're pretty much at the end here.
So next week is part 2.
I'll do part 2, but it won't be on the final. I figured out, because I had to get so close to the end, I don't feel like doing it to you. But there's plenty of information about Android to make a good final, so that's what I'm writing. And the final is optional anyway. You don't have to take it, but it's available for a week to take online if you want to. And
you have extra credit quizzes, I saw at the bottom.
Yeah, there's a lot of extra credit quizzes. There's two in this session. In this, there's 2 there. In the other class, there's an extra one on blockchain. Yeah, there's some extra credit quizzes in addition to extra credit projects. That's why I should have an easy A on Rate My Professor. I don't know why I don't. Anyway, all right, so I think there's like 3. I think half the book is iOS, and we didn't cover it. We're only going to do the first one. We're not covering it thoroughly at all because I wasn't willing to go there because I don't have the ability to be hands-on iOS projects. I have plans to overcome that, but until I've overcome that, I'm not covering it. I skipped it this semester. Any questions about anything? Well, I'm just going to turn off the share and I'll go upstairs and see if anybody wants help with projects. Just in time.
This is the cyber meeting, right?
What cyber meeting?
Yep, yes, sir.